In this lesson, you will memorize different terms relating to prisms, as well as calculate the lateral area, total area, and volume of prisms. So as we begin, there are many different terms that you need to know. So let's begin with the term prism. A prism is a solid geometric figure whose two end faces are similar, equal, and parallel figures, and whose sides are parallelograms. And here we see three different examples of prisms. Now there are types of prisms that we have as well. The first is what we call a right prism. A right prism, by definition, has lateral faces that are perpendicular to the bases. So the bases would be like the top and the bottom, and we see here in the blue would be the bases for these two, and then the rectangular one, the bases would be the top and the bottom. So the bases are perpendicular to the lateral faces. So notice the top two would be perpendicular, whereas the bottom one down here would not be. In addition, the lateral faces are rectangles. So the sides of the top two prisms, of the triangular one and the rectangular one, the faces are rectangles. Whereas the bottom one is what we call an oblique prism, and notice how it's tilted on the side. So lateral faces are not perpendicular to the bases, and the lateral faces would be parallelograms and not rectangles. So the main idea here is if it's slanted, like the bottom one, that is oblique prism, and then the other two that are just upright, not slanted, would be a right prism. In addition, we can name prisms based off their bases. So first we have a triangular prism, which would be the top one, because the bases are triangles. The next one is rectangular prism, because the bases are rectangles. And then the third one here at the bottom would be a pentagonal prism, because the bases are pentagons. And whatever shape we have for the bases, we can name that prism by the base. So if we had a hexagon for a base, we would call it a hexagonal prism. If it was an octagon for a base, it would be an octagonal prism. So the base will signify the type of prism that we have. Now with the rectangular prism, we have parts of the prism you need to be aware of. The first is the base. So the base are, by definition, the sides that are parallel. But in this case, we have every pair of sides will be parallel. So with the rectangular prism specifically, the bases will be the top and the bottom. So right there in the bottom and on the top, that would be your bases. We also have what we call the altitude, which is a segment that joins the two bases and are perpendicular to each. So we see here in yellow, over here on the side, this would be the altitude. It is connecting the top and the bottom, the two bases, and is perpendicular to each of them. Next we have the height, which is the length of the altitude. So for our intents and purposes, altitude and height would probably be used interchangeably for the most part, but there is a slight nuance in the sense that the altitude would be the segment that connects the two bases, and the height is the length of that segment. And then we have the width of the prism, which would be how wide it is. So this line right here would be the width, and the length is how long it is. So right here at the bottom would be your length. Next we have what we call the lateral faces, and the lateral faces are the faces that are not the bases. So not the top and the bottom, but we see here in the front, the back, the right, and the left side, those would be your lateral faces. Next we have the lateral edge, is where the lateral faces meet. So right here in yellow, it's kind of hard to see in this slide, but here in yellow would be the lateral edges, which is where those faces would meet. For a triangular prism, the terms are the same as with a rectangular prism. We have the base, which would be the sides that are parallel, and then we have the altitude, which is the segment that connects the two bases. So right here in red would be the altitude, and the height is the length of that altitude. By the way, take note with the term base. So base are the sides that are parallel. So even if I were to rotate this triangular prism, where the base is not on the top and the bottom anymore, then the parallel sides, the triangles, would still be the bases, even though it's not technically in the top and the bottom anymore. So for example, here is a triangle that's rotated, so now the bases would still be the triangles, but they're not on the top and the bottom. So base would be the sides that are parallel, altitude would be connecting the bases, so this segment right here would still be the altitude, even though it's sideways in this case. And then the height is the length of that altitude. And then we have what we call the lateral faces, same as with rectangular prisms. These are the faces that are not the bases. So those rectangular faces, everything that's not the triangle, would be considered a lateral face. And the lateral edge are where those lateral faces meet. So right here would be a lateral edge, then back here would be a lateral edge, and then right here would also be a lateral edge. So those would each be lateral edges. And then with a pentagonal prism, still the same terms, but now in the context with a pentagon. The base would be the parallel sides, so in this case would be the pentagons. The altitude would be the segment that connects the two bases, and in this case that would be the red line going from the top base to the bottom base. And the bottom base we kind of had to extend a little bit to make the altitude actually hit both bases, but this red line would be the altitude. And then the height is the length of the altitude, or the distance from base to base. We also have lateral faces, which are the faces that are not the bases. So everything that is not the top and the bottom would be a lateral face, meaning each of the parallelograms that are on the sides would all be lateral faces. And then lateral edge is where those faces meet. So these yellow lines going down, that would be your lateral edges. Now we need to use those terms to begin calculating what we call the lateral area, and then the total area, followed by the volume. So the lateral area, by definition, is the area of the lateral faces. Now the lateral faces will be rectangles in this case. So the faces, what we're doing is we're finding the area of each of those rectangles. So the area of the front rectangle, and then the back, and then the two sides. By each rectangle, we can find the area of each rectangle by taking the base times the height. So in this case, we have the length times the height would be the area of this first rectangle. And then the back rectangle would still be the same measurements, be the length times the height to find that back rectangle. And then to find the one on the right, base times height of the rectangle. In this case, we have the width times the height, and that is how we find that face. And then the face on the left would be the same as well. We have the width times the height to find that area. So to find the total lateral area, we add up each of those areas together. So when you add those areas together, we have length times height, plus length times height, plus width times height, plus width times height. So what we can do from here is we can pull out what each of these terms have in common, and that would be they each have a height in common. So I factor height out, and I'm left with, in parentheses, the length plus width plus width. While length plus length would give you two lengths, and width plus width would be two widths. And notice what that gives us. We have a length plus another length plus a width plus a width. Well, if we add all those together, that gives me the perimeter of the base. So we can replace the 2L plus 2W with perimeter, or perimeter of the base. So the lateral area would equal the perimeter times the height. And this is the shortcut formula that we can use to find the lateral area. And another way of maybe thinking of this is we have the four rectangles, and we know the area of a rectangle is base times height. And we have 4 rectangles in this picture for the lateral faces. We have the left, right, back, and the front. And instead of doing each rectangle separately, what we are doing is we are doing them all at one time. And so looking at the base of each rectangle, so the base of this right one, the one in the back, the one on the left, and the one in the front, if we add all those bases together, we get the perimeter. So we get the perimeter of the base times the height. So this is for the prism, and then this is for just one rectangle. Okay, so maybe another way of thinking through that. Now looking at an actual example. Here we are told the length, width, and height of this rectangular prism, and our objective is to find the lateral area. Well, the lateral area is the perimeter of the base times the height. So the perimeter of the base, I take the length of 10 plus the width of 6 plus another length of 10 plus another width of 6. So we add all those together, and I get 32 for the perimeter. So 32 is the perimeter, the height is 4 inches, so we have 32 times 4, which would give me 128 square inches. Now to find the total area of the rectangular prism, what we do is we take the lateral area, and then we're going to add in the top and the bottom. So we're taking the area of all of the faces plus the 2 bases. So that is the area formula to find the total area. Well, we found the lateral area already to be 128. And then adding in the 2 bases, we have one base is 10 inches, and then the height is 6 inches. So the area of that rectangle, we take 10 times 6 to get 60 for one base. So one base is 60 square inches, so 2 bases would be 120 square inches. So I add that to the lateral area to get a total area of 248 square inches. And now the volume of a rectangular prism, what we are doing is we're taking the area of the base and multiplying it by the height. So the area of the base times the height, we use a capital B to represent the area of the base. And so the area of the base would account for the 2 dimensions of the rectangle, and then the height you multiply by to account for that 3rd dimension to find the volume. So here, area of the base, we already found to be 10 times 6, which would be 60. And then the height is given to you as 4. So I take 60 times 4 to get a volume of 240, and the units would be inches cubed. And a way to remember that it's inches cubed is because we are dealing now with 3 dimensions, working with the volume. And so 3 dimensions requires the units to be raised to the 3rd power. And another way of thinking of this with the length and with the area and volume, so length is 1-dimensional. So if we have 1 dimension, let's say the units are in inches. Well, we just have the units in inches for 1 dimension. For 2 dimensions, what we have is something like base times height. So it's going to be something like 3 inches times 4 inches. So what we have is going to be 3 inches times 4 inches gives me inches times inches, or inches squared. And then for 3 dimensions, we're going to have something like in this scenario, where you take inches for the length, times that by inches for the width, times that by inches for the height, which gives you inches to the 3rd power. So either way you want to think of this, you can think of this as multiplying the units, or you can think of this as 1 dimension would have inches to the 1st power, 2 dimensions would have inches to the 2nd power, and 3 dimensions would have inches to the 3rd power. Now let's take a look at triangular prisms. With any type of prism, the formulas will always be the same. The only difference would be when you're trying to find the area of the base, then you're dealing with a different area formula for the base, but everything else is the same. So lateral area formula is perimeter of the base times the height. While looking at the base is the triangle. So the perimeter of the triangle we find by taking 6 plus 4.5 plus another 4.5. When you add those together, you get 6 plus 9, which gives me 15 for the perimeter. And the height is the height of the prism. So the height is 10, so you multiply 15 by 10 to get 150 square inches. And then total area, you take the lateral area, and then you add in the two bases. So the lateral area we already found to be 150 square inches. And then to find the area of the base, we need to find the area of the triangle. So the triangle formula is 1/2 times the base of the triangle times the height. So the base of this triangle is 6, but the height we don't know. So I need to find that height so I can plug it in to find the area of the base, so I can find the area of the entire prism, the total area. So finding the height, I need to use the Pythagorean theorem. And using the Pythagorean theorem, I'm only concerned with this right triangle over here on the left side or on the right side. So looking just at this right triangle, we have this side is 3 inches, the hypotenuse is 4.5 inches, and then the height is what we're trying to find. So Pythagorean theorem says a squared plus b squared equals c squared, where c is your hypotenuse, which would be across from the right angle, so 4.5 would be your c value. So plug 4.5 in for c, plug a 3 in for either a or b, and then you solve this for h. So 3 squared is 9, 4.5 squared is 20.25. I can solve for h by subtracting 9 from both sides, and I'm left with h squared equals 11.25. And then from here, I can solve for h by taking the square root of both sides. When I take the square root of a square, that will cancel. I'm left with h equals 3.35 inches. So I found the height, so now I can find the area of that triangle by plugging in the height of 3.35, the base we said was 6, and then multiply those together. I get a base of 10.05. But there are two bases, so I need to multiply that by 2 to give me 20.10 square inches. Add that to the lateral area to find the total area. When I add those together, I now get 170.10 square inches. Now to find the volume, we take the area of the base times the height. The area of the base we just found to be 10.05. The height is the height of the prism, so this 10 inches is the height of the prism. Multiply those together, I get 100.5 inches cubed. So to recap on all the formulas, here we see the lateral area is perimeter of the base times the height. Total area is the area of everything, so the lateral area plus the area of the two bases. And then the volume is the area of the base multiplied by the height of the prism. Here's one last example with what we call a cube. A cube, by definition, is a rectangular prism with all the edges being the same length. And all the formulas still apply for a cube as they do for a rectangular prism. So in this example, the lateral area we find by taking the perimeter of the base, multiply that by the height. So perimeter of the base, we're dealing with a square base, so the perimeter of this square would be 3 plus 3 plus 3 plus 3, which would be 12. And then the height is this other 3 right here. So 12 times 3 would give you 36 square inches. Total area, you take the lateral area, then you add in the area of the two bases. So the lateral area was 36, and then the two bases we find by finding one base first, and the base is a square. So the area of one square would be base times height, or 3 times 3, which would give you 9. And then for the total area, we have to add in two bases. So we have 2 times 9, or 18 square inches. So the total area would be 36 plus 18, which would give me 54 square inches. And then the volume is the area of the base, which we just said to be 9. Multiply that by the height, which would be 3. So 9 times 3 would give you 27, and then the units would be inches cubed. Now a quick little shortcut that we have for total area and volume. Total area, if we think of this, we have every side, including the top and the bottom, are all squares. Well, the area of a square would be side times side. So side times side would give you the area of one square. So one square would be side squared. But with a cube, we have 6 sides, so we have 6 times s squared. So this is a shortcut formula that we can use to find the total area. And then I guess even for the lateral area, we have 4 sides that we're dealing with. So everything but the top and the bottom. So we have 4 s squareds for the lateral area. And then for the volume, we have the area of the base, which is side times side, multiplied by the height, which is the same length as the side. So we take side times another side, which would equal side to the 3rd power. So if you wanted, you could use these 3 shortcut formulas to find lateral area, total area, and volume, or we could just use the regular formulas if you prefer. And that concludes our lesson for today. We will see you next time.